So once you have this planning done, and then you have the passive site survey done, you have first from the planning a guesstimation of the number of access points, and then maybe some possible locations of those access points. Then you went on site and you did a passive site survey. If you used a layer 2 tool, you may have a good view of the 802.11 environment. You may also have done some scanning at the RF level and have a good idea of the non-802.11 environment. Now it's time to try to decide where you want to put your access points. And maybe you're not entirely going to trust the tool that gives you the planning. You'll have to decide on site with a real RF environment, with the real obstacles that we didn't have in the tool, to put your access points where they should be. So how do you do it? Well, there are a few methods, and none of them is better than the other. It depends on your habit, depends on how you were trained. It depends also a little bit of your use and the environment where you are, where you think that one method may be more efficient in that case than some other. So one common idea is to try to design Wi-Fi for areas where you know you will need an access point in those areas. For example, meeting rooms. You may say, it's going to be a high density of people there, so I know right there I will need an AP in each of those. So I'm starting to design my network by assuming one AP in each of these locations. And once you start from there, you use the coverage from those access points to try to determine the other access points in the rest of the floor. Another technique is to start from something that is a heavy obstacle to Wi-Fi. For example, stairwells or elevator shafts. You know that those are not going to let the signal work through. So you're going to start from those as being a sort of wall from where Wi-Fi is not going to spread across, and use that as a place from where you'll be deciding on the first cell and then moving away from those big absorption area. The last method is simply to start from the corner of a building. So again, all these methods are valid. Just decide the one which is most relevant to where you are. If they have a lot of meeting rooms, maybe you want to start from there. If there are a lot of obstacles, maybe you want to start from there. If it's an open space, maybe you want to start from the corner of the building. But in all cases, let's look at how you would position your access point, what is commonly done. And again, there are many techniques, that's just one of them. Suppose you start from the corner. What you would do is, first of all, decide what is the edge of your cell. What is the signal level that you want to have at the edge of your cell. And remember, that signal level is going to be driven by the data rate you want to achieve at that edge of that cell. So suppose that you designed for a standard voice deployment with a standard density of devices, and you determined that the edge of your cell should be at minus 67 dBm. That's the RSSI that the access point should have on the particular device that you're using for the site survey, and that's going to be your client. Remember, you have to survey with the client you expect, and if you cannot survey with the client because you have a tool on the laptop, you have to bring the client along with the laptop to understand the difference in signal between the laptop and the real client. So you can use the laptop to imitate what the client would see. So again, assume that your cell edge is at 67 dBm. What you can do is position the access point right there at the bottom on the corner, and then you're going to walk away and measure the area where the signal is at minus 67. That would be the edge of your cell, of course, if your AP was to stay in that corner, which is not going to be the case. Once you've done that, you move your AP in a 45-degree angle away from the corner of the building, and you position it exactly at that point where you had that minus 67 dB signal, 45 degrees away from the angle. Why is that? Because simply if you have the AP in the corner and you have 67 dB at that point, well, now if you bring the AP at that point, you should have exactly the same logic the way around. So you should have 67 dB at the corner. So that gives you the idea that your cell is going to expand all the way down to the corner with the right level of signal that you need for your cell. So you position the RAP here, and then of course you measure the signal again at this minus 67 dBm edge away from that access point. That is your first AP. That's where it's going to be, and that's the size of your first cell. All right, so that was the hard part. Next, you have to move and put the next AP. So how do you do it? Well, it's a bit complicated because it depends on, again, the environment, where you go from there. But suppose you are going to go up and position some other access points on the way up. You know what the distance is now between that access point and the edge. You can measure that on site, right? X meters, X feet. And your job is to try to position the next access point with a certain number of requirements. One, if you design for voice, which was my example, you want consistency of coverage, which means you don't want any coverage gap. Two, you probably want some overlap between the cells so that you make sure that as you get away from the first access point, your device has the time to discover the next access point before it actually gets to the edge of the cell and has to jump to the next access point. So typically, we talk about 20% overlap for voice. 20% overlap, what does that mean? Well, let's do some math and let's show you why you don't want to do some math. If you take a circle and then you take your next access point cell, when we talk about 20% overlap, we talk about this, the area, right? So it's not a 20% distance overlap, it's a 20% area overlap. So how do you measure the overlap between two circles? Well, if you love math, you may know how. If you're not a very mathematical mind, then you may not know that there are plenty of equations that try to solve that problem. So there are many ways of solving that problem. Some of them are approximations, some of them are more precise, but in any case, there is one which is commonly used in the RF world, which is taking the radius of the circle made by each of your cell, and for simplicity, I'm going to assume that your access points are the same, so your cells are the same, so the circle are going to be the same as well. And there is an equation that says that 20% overlap is basically a ratio of the distance between the access point that is calculated from the radius with that equation. All right, I'm not going to give you all the equations and how the mathematical reasoning is done, but basically, if your radius is whatever distance, the distance from one AP to the other that allows you to have a 20% overlap is going to be 1.374 times the radius. So if your radius is 10 feet, you multiply this by 1.374, and that's going to be the distance between your two APs. Of course, 10 feet is an example. I hope that your radius is going to be larger. But you see the concept. Multiply your radius by 1.374, and that gives you the distance at which your next access point is going to be. That is for a 20% overlap, which is common for voice. You also find something about 10% overlap for data, and that is the ratio between your distance and your radius if you use 10%. If you have a very aggressive coverage and only 15% overlap and you still want to do voice, that's the equation. So those are numbers. You can find more numbers online and you can find the equation online if you really want to, but let's make it simple and think that you just know this number and you don't want to bother about why that number came to be. The result is that once you have that access point and you know the distance from the AP to the point of the cell where you have this minus 67 dBm, you have that distance. Well, the only thing you do is that you multiply it by this equation. Most people use 1.4 as an average. That gives you between 15 and 20% type of coverage. And they just decide that this is the distance at which the next access point is going to be. So now you have the first AP. You know where the second AP is going to be because that's 1.4 times the radius of the first one to that point at minus 67. And then you have the second access point that you can measure. Once you have the second AP, you have, of course, the coverage that you can measure as well, and you can just copy the same method again. Measure where you get minus 67. Typically, if the APs are the same, it's going to be the same distance as the first one, unless the environment is changing, you have different walls, etc. So in that case, you may have to measure. And then you take that distance from the AP to 67 dBm times 1.4, and that's the point where you have the next AP, etc. And you keep on moving.